Hey everyone, today we're going to talk about leveling up your Python game. We're diving into two incredibly powerful tools, list comprehensions and generator expressions, that are seriously going to change the way you write your code, making it cleaner, faster, and just way more, well, Pythonic. You know that feeling, right? You're staring at a perfectly functional for loop, but something in your gut is telling you, this feels clunky. There has to be a better way to do this. And you know what? You're absolutely right. There is a better way, and that's exactly what we're going to get into.
All right, so first things first. Let's start with the familiar, the classic, the good old for loop. It's reliable, it gets the job done, but let's be honest, it can be a little verbose.
Okay, check this out. A super common task. You've got a list of numbers, and you want to make a new list with the square of each number. The traditional way is right here. You create an empty list, you loop through the original numbers, you do the math, and you append the result. I mean, it works for sure, but look at it. It takes 4 whole lines of code to get one simple idea across. We can do better.
So what's the elegant solution I'm talking about? Well, let me introduce you to one of my absolute favorite features in all of Python, the list comprehension. This is where your code goes from just working to being genuinely expressive.
And bam! This is the magic right here. On the left, you've got that 4-line slog we just talked about. On the right, one single, beautiful, easy-to-read line that does the exact same thing. This transformation, this jump in clarity and conciseness, this is what being Pythonic is all about.
So how does this work? It's actually incredibly intuitive once you see it. It all starts with the square brackets. That tells Python, hey, we're making a list. Then inside, you have 2 parts. First, the expression, what you actually want to do to each item. And second, the loop part, the for-item iterable. It practically reads like a sentence. Give me this expression for every item in this collection. So clean.
But wait, there's more. List comprehensions aren't just for transforming every single item in a list. What if you need to be a little pickier? What if you want to filter things out and apply some logic? Yep, they handle that with the same elegance. Let's say we only want to grab the even numbers from a list. The old way would be to nest an if statement inside our for loop. Again, it works, but it's another layer of indentation, another line of code. But with the list comprehension on the right, you just tack that if condition right onto the end. It's like you're just adding a filter. It's so direct.
So the key takeaway here is just how neatly that if condition slots in at the end of the syntax. Python essentially goes through each item, checks if it passes your if statement, like a gatekeeper, and only if it gets the green light does it then apply the expression. It's a filter and a transformation all in one powerful line.
Okay, list comprehensions are a superpower, no doubt about it. But even superheroes have a weakness. For list comprehensions, that weakness is memory. See, it builds that entire new list in memory, all at once. For a few hundred items, who cares? But what if you're dealing with millions or even billions of items? Your computer is going to have a very bad day. And that's when we need an upgrade.
And this quote right here just nails it. Think about it this way. A list comprehension is like printing out a 1,000-page report and dropping the whole stack on your desk. A generator expression is more like a machine that prints out 1 page at a time, but only when you ask for it. It doesn't store the whole report, it just yields the next page on demand. It's incredibly memory efficient.
And get this, the syntax is almost ridiculously simple. You just swap the square brackets for round parentheses. That's literally it. But notice what happens when you print the result. You don't get a list of numbers. You get this thing called a generator object. That object isn't the list itself. It's the promise of a list. It's the recipe, just waiting for you to say, okay, start cooking. So how do you get the values out of that recipe? Well, you have to consume the generator. You ask it for the items. You can do that by looping over it, or, like we're showing here, by forcing it into a list. The moment you do that, the generator wakes up and starts producing the values one by one. This awesome concept is called lazy evaluation. It does absolutely no work until the very last moment it's needed.
So when do you actually use a generator? Simple, when your data is huge. Think about processing a massive log file that's gigabytes in size, or handling data streaming in from an API. Anything that's just too big to load into RAM all at once. In those cases, a generator isn't just a nice-to-have, it's pretty much the only way you can do it. A great rule of thumb, if you only need to loop over the results once, a generator is probably the right call.
All right, we've covered a ton of ground.
So let's boil it all down into a really clear guide so you know exactly which tool to grab for the job.
This table is your ultimate cheat sheet. Let's walk through it. For syntax, it's square brackets for list comps, round parentheses for generators. Simple. The output? A list comp gives you a brand new list right then and there. A generator gives you that generator object, the recipe. And now for the big one, memory. List comprehensions store the entire result at once, eating up RAM. Generators are lazy, yielding items on demand, just sipping memory. This brings us right to the use case. Need the list right away? Working with smaller data? Or need to loop over it multiple times? Go with a list comprehension. Working with huge data, streaming, or just making a single pass, the generator expression is your best friend.
Mastering these two patterns will instantly level up your Python skills. Your code will become so much more concise, more readable, and a lot more efficient. So I'll leave you with this challenge. Go take a look at your own code. Find a clunky old for loop. Which one will be the first you refactor into an elegant one-liner? Thanks for watching.